Welcome to the College Algebra Lesson 18 demo. We're going to let h be a function of t, and the formula is 6 plus 2t. It represents the height of corn seedlings in inches, t days after they're planted. Make a table of values for f of t over the domain 0 to 3. So if I plug 0 into my f of t function, I have 6 plus 2 times 0 is 6. 6 plus 2 times 1 is 8, 6 plus 2 times 2 is 10, and 6 plus 2 times 3 is 12. Write the set of ordered pairs t comma h from the table. So I have 0 comma 6, 1 comma 8, 2 comma 10, and 3 comma 12. Suppose I wanted to know how many days t it would take for the height of the seedling to reach h inches. How would I find t? Start with your formula and solve for t. So you start with h equals 6 plus 2t. Solve for the t, just like similar to what we did in the preview exercises, right? So this is going to be h minus 6 equals 2t. Just subtract 6 from both sides, then divide both sides by 2. T is h minus 6 over 2. In this equation that we just created here, h is now the input and t is now the output. We interchanged the roles of the variables. So let's create a new table for the values of this function. H is the input, t is the output. So when h is 6, 6 minus 6 is 0 over 2 is 0. When h is 8, plug an 8 in here for h, and you get 8 minus 6 is 2 over 2 is 1. 10 minus 6 is 4 over 2 is 2, and 12 minus 6 is 6 over 2 is 3. The set of ordered pairs h comma t is going to be 6 comma 0, 8 comma 1, 10 comma 2, and 12 comma 3. So to summarize our observations about the functions f and g, right? So here's where t is my input and h is my output. Now when h is my input and t was my output, I have 0, 1, 2, 3. The tables just flip-flopped, right? The x and y coordinates just changed roles. Right? Inputs and outputs swapped. We call these two functions, I'm using x now as my variable instead of h's and t's, but f of x is 6 plus 2x, and g of x, which is x minus 6 over 2, we call them inverse functions. The fact that g is the inverse of f is expressed by renaming g as f inverse, right? So it looks like raised to the negative 1, but you would read that as f inverse. It does not mean f raised to the negative 1. So you would have, if f of x is 6 plus 2x, f inverse of x is x minus 6 over 2. All right, so the really big idea here, the definition of an inverse function. F and g are two functions so that when you compose them, you get x, right? So you get a round trip. If you compose your two functions, you get a round trip. You get your x back. So you plug x into g, plug the result into f, and whatever you plugged in, you get back. Okay, so that's the definition of an inverse function. So the two functions that create a round trip. So here's my, my two example functions. I have f of x is 6 plus 2x. Its inverse is x minus 6 over 2. Let's check that we get a round trip, right? What is f of 10? Okay, so here's my formula for f. Plug a 10 in for x. And so I have 6 plus 20 is 26, right? So f inverse of 26, when I plug 26 into the f inverse function, I should get 10 back, right? I should get my original input back because I input 10, I got 26. If you put 26 into the inverse, it should give you the 10 back, but let's just double check, right? 10 minus 6 is 4 over 2. Oh, sorry, I'm plugging 26 in. 26 minus 6 is 20 over 2 is 10, right? So I plugged in 10 as my original input, and I got 10 back. So f and f inverse give me a round trip. Let's verify that this works for every single x. F composed with f inverse, right? So f inverse of x is x minus 6 over 2. So that means that f of f inverse is f of x minus 6 over 2. So that means look at your formula for f. Everywhere you see an x in it, you have to replace it with x minus 6 over 2. So I have 6 plus 2 times x minus 6 over 2. To simplify this, my 2's cancel. So I have 6 plus x minus 6. The 6's cancel, and I just get x. So I do have a round trip, right? My original input was x. If you plug into f inverse and then the result into f, you get x back. And the reverse should also work. Okay, so my f of x is 2x plus 6. So f inverse of f of x is really f inverse of 2x plus 6. So what that means is in your f inverse formula, this guy up here, if you replace that x with a 2x plus 6, you have to replace every x in the formula with a 2x plus 6. So that's going to be 2x plus 6 minus 6 over 2. The plus 6 and the minus 6 cancel, so you have 2x over 2. 2's cancel, and you get x. So I do have a round trip, right? I originally plugged in an x. I applied both functions, first f, then f inverse, and I got x back. So we verified that those two functions are in fact inverses of each other.